In our next video, we're going to take a look at the functions of the sympathetic and parasympathetic divisions. So we've got two different divisions, and we're going to see that every organ gets input from both. So one of these is going to speed the organ's functions up, the other one's going to slow the organ function down. Or one of them's going to cause the gland to secrete, the other one's going to cause the gland to stop secreting. So we need to take a look at how we divide, or how we know what's going to happen with each organ depending on whether we stimulate sympathetic nervous system or parasympathetic nervous system. So this picture is to show you that if you look at any of the main organs of the body, they are all getting input from both of these divisions. So check it out. The sympathetic neurons are these green ones. They start inside your spinal cord. Here's neuron number 1. And then here's neuron number 2, and it's going out to each organ. Okay? So check out the heart. Is it getting a sympathetic innervation? Yes, it is. Now over on this side, these purple neurons, these are the parasympathetic neurons. So the parasympathetic neurons are coming out of the brainstem, or they're coming out of the sacral part of the spine. And again, you can see, is the heart getting a parasympathetic input? Yes, it is. So if you look at any of these organs, lungs, is lungs getting a sympathetic input? Yes. Is lungs getting a parasympathetic input? Yes. Is stomach getting a sympathetic input? Yes. Is stomach getting a parasympathetic input? Yes. So they all get inputs from both, and it's the balance between the two that decides how fast the heart is going to beat, how fast we're going to breathe, how quickly we're going to digest food. It's going to be a balance between how many inputs are we getting from sympathetic nervous system and how many inputs are we getting from parasympathetic nervous system. So the key thing to remember with this is anything you would turn on in a fight or flight situation is going to be sympathetic nervous system. So your sympathetic neurons turn on when you are scared, excited, embarrassed. Any kind of emergency is going to turn this system on. So you got to think to yourself, if I had to fight or if I had to run away, what would I need my body to do to help me do that the most efficiently that I could, right? So does it make sense that when you are in fight or flight mode, you want your heart to beat as fast as possible and pump as much blood as possible? Pumping blood is going to send that blood to your muscles, helping you run away, okay? Does it make sense that your blood pressure would get higher? Blood pressure helps push the blood so it can get to where it's going. Getting extra blood into your lungs for breathing and gas exchange, getting extra blood into your skeletal muscles for helping them to work better and harder and faster, that's a good idea, right? And again, breathing harder, breathing faster, breathing deeper, widening all those tubes that are inside your lungs so you can get the maximum airflow into your lungs, that should happen when you turn on your sympathetic nervous system, okay? So think to yourself, what would help me fight or what would help me run away? And I guarantee you that the sympathetic nervous system will turn on when you're in that type of situation. Okay? Now, two things we don't have to worry about when we're in fight or flight mode is digesting food or making urine, right? Because think about it, in those two situations, digesting food isn't going to help you if you get eaten by a lion, right? So usually when you turn on sympathetic nervous system, you actually turn off these other two systems. Usually you turn off digestive and you turn off urinary, okay? So a lot of the times, if you're really nervous, really anxious, really stressed, you don't feel like eating because your digestive system has been turned off by your sympathetic nervous system, okay? So the other arm, the parasympathetic, the thing we remember for this one is that parasympathetic is for rest and digest, okay? So rest and digest, anything that would be involved with those two processes will be turned on by the parasympathetic nervous system. So it's no surprise to us that everything in your digestive system is turned on by parasympathetic neurons. Getting all the secretions that have enzymes that do digestion, that's turned on by parasympathetic nervous system. Making the smooth muscle squeeze faster so you can push the food through the tube and keep things moving, that's parasympathetic nervous system. You'll also notice that in the morning when you wake up after a long sleep, the first thing you have to do is pee. That's because your urinary system has been working hard all night long making urine for you. So parasympathetic will turn on everything that's involved with resting and digesting. So think about it. When you're resting, what's your heart rate like? It's usually pretty slow. When you are resting, what's your breathing like? It's usually low and shallow, right? What's your blood pressure like when you're at rest? Very low, calm, quiet, right? So you can see how these two systems work together. And usually when you're turning on sympathetic, you're turning off parasympathetic, right? And when you're turning on parasympathetic, you're turning off sympathetic. So if you've ever had a class at 1 p.m. right after lunch, you've experienced parasympathetic rest and digest, okay? You just had your nice large lunch. You turned on your parasympathetic nervous system to start digesting that food. What does your brain want to do now that you're digesting? It wants to rest, right? So sometimes it can be very hard to concentrate, very hard to focus after lunch. Your body goes into rest and digest mode and you're feeling a bit sleepy and not your most alert. But if your instructor says, pop quiz, we're having a quiz on this right now, that will turn on your fight or flight mode. Sympathetic nervous system will turn on and you'll immediately become more focused and more ready to do great on that quiz. So we see these systems coming on every time we get a fright and every time we go into rest and digest mode. Okay? So we can think about, how would the parasympathetic division affect the autonomic nervous system? Or how would the parasympathetic division affect the heart? Okay? If you go into rest and digest mode, does it make sense that your heart rate should slow down? Yes. And the reason that this is happening is that acetylcholine tells the cardiac muscle to slow down. So when those parasympathetic neurons send action potentials, they release acetylcholine onto the cardiac muscle receptors, and the cardiac muscle will slow down. Okay? So acetylcholine of the parasympathetic division will slow down the heart. But how will acetylcholine affect the digestive system? Acetylcholine from parasympathetic neurons will tell the digestive system to turn on, right? So this is the same neurotransmitter, acetylcholine, in both cases, but because there are different receptors in your digestive system than there are in your heart, acetylcholine can tell smooth muscle to speed up and cardiac muscle to slow down. So it's a pretty cool system. Because the cells all have different receptors, the same neurotransmitter can do two opposite things in two different places, right? So you can have two very different effects in different organs because there are different receptors, right? The heart will have receptors that cause hyperpolarization, kind of slowing it down and turning it off a little bit. And the digestive system will have receptors that cause depolarization, speeding it up and turning it on more. So the same neurotransmitter can have two very different effects in two very different places. All right, we're ready for our next video.